so close to the edge of the water as I fell.
Okay, so we're going to find a constant c that makes our function f of x for this and that continuous. So f of x is actually a piecewise function, meaning that it actually takes on properties of like other functions of two or more different functions for different x values. Okay, so for continuity, just a refresher here. So continuity, we have to have this. Remember our equation, our all-important number equation number one, be true. So limit as x approaches some c value of our f of x has to equal the value of our function at that point at c, x equals c. Okay, so first of all, we have to ensure that the left side even exists, that limit exists, and we do so by making sure that the left and right hand side limits, that those sided limits agree with each other. Because if they don't agree, then that means we have a jump discontinuity, and this limit, this boxed limit, doesn't even exist. So this is what we have to do. This is a general way of writing it. And now, more specifically to our problem, we're going to plug in a 5 for c. So as the limit of x approaching 5 from the left. So 5 from the left means that we're coming from x values that are less than 5. Okay, they could be negative, they could be 0, or anything less than 5. Okay, so that means that we have to use this part of our f of x. That's going to be x squared minus c. And then for the right side, we have a limit as x approaches 5 from the right side. So that means from x values that are greater than 5. So we'd use this one. So that means 4x plus our 2c. So first of all, we have to fulfill this. This is an important first equation in order to solve for c. So what we're going to do on the next slide is plug in these 5's for x's. So what we get is 5 squared plus, or sorry, not plus, minus c. And then on the right side, we have a 4 times 5, which was subbed in for the x, plus 2c. Okay, now we're just going to solve. So 25 minus c equals 20 plus 2c. And then if we subtract 20 on both sides and add this c over to the right side, okay, so this cancels out, that cancels out, and we get 5 equals a 3c. So our c is presumably 5 over 3. Okay, so that's our c value, but let's check to see if that's true. So this c value here, that makes our left and right hand limits agree with each other. So limit as x goes to c, or 5 in this case. So, well, no, sorry. This is a different c. So as x goes to 5, we'll say, of f of x, we know that this exists according to this constant value here, if we have this constant as our c. All right? So now let's see, let us see, S-E-E, if the limit as x approaches 5 of f of x is actually equal to our f evaluated at that point, c. So let's see. Let us see. We'll check this on the next slide where we have more room, okay? So if we check that, all we have to do is do limit as x approaches 5, and this means 5 on the dot, so that means that we have to use the x squared, well, we can use either one really, but I'll just use the x squared minus c one. So I'll plug in 5 over 3 for our c value. So this is going to be, let's see what we have here. So this is continuous at 5. So we just plug in a 5. So 5 squared minus 5 over 3 is 25. 25 minus a 5 over 3, which is equal to 75 minus 5 over a 3. Well, this is also, yeah, I could just write this as 23 and 1/3. Okay, so that's our answer of the limit. That's of our left side. And now let's see f of c, which is the same as f of 5. Remember our conditions. So when x was greater than or equal to 5, our function was the 4x plus 2c1. Okay, so this is what we're going to use because we want 5 right on the dot, so we want this equal sign here. So that's going to be f of 5. Yeah, so f of, let's see. Okay, yeah, so we have our f of 5, so that's going to be 4x plus 2, and we figured out that our constant c, sorry there's so many c's going on, they whoever made this problem used the wrong constant letter. We should use like a K or something. But anyways, so 2 times 5 over 3, that's what we found for C value. Okay, and we're going to plug in 5 for our X. Okay, so let's see what this comes out to. 4 times 5 in for X plus 10 over 3. That's equal to 20 plus 10 over 3, and that is a 23 and 1/3. Okay, so these agree with each other. This is the value of the function at our given value, which was 5. Okay, and this up here, that one was the value of our limit as x approached 5 of our function. Okay, so these two agree with each other, and we're good. And again, our C value, our constant value, the one that we were solving for, not the one that's involved in like what x approaches. But anyways, our constant value turned out to be a 5 over 3. Okay?
I slip away.